Okay, folks, I want to make a little addendum to our decibel scale discussion. In particular, I want to talk about how you would find the gain in unitless, V out over Vn, for example, if you know the gain in dB. Okay, so we start by first reminding ourselves what was our expression for the gain in dB. So G sub dB, that's our gain in decibels, is equal to 20 times the log base 10 of V out over Vn. Right? What we want to solve for now is V out over Vn. So we're going to make use of the rules for exponential functions and logarithmic functions in order to do that. But first we've got to divide both sides by 20. So we have the gain in dB over 20 equals the log base 10 of V out over Vn. All right, so now we want to use each side of the equation as an exponent with a base of 10. So we're going to do that over here. We'll say 10 to the G dB over 20 equals 10 to the log base 10 of V out over Vn. And we know that if we have 10 raised to the power of the log base 10 of something, then we just get that something back. So that tells us then, taking this expression and rearranging it, we know that V out over Vn equals 10 to the power G sub dB over 20. And that's how we do it. Okay, so just a quick reminder also, if we have a power ratio instead of a signal amplitude ratio, remember we would have the gain in dB is equal to 10 times the log base 10 of P out over Pn. Okay, and again, we want to solve for P out over Pn. It works exactly the same way. The only difference is this factor of 10 here instead of 20. So we can just jump to the conclusion here, and we can say that the unitless ratio, unitless gain, P out over Pn, is going to be 10 to the power of the gain in decibels divided by 10 instead of 20 as with signal amplitude. So let's work some examples. So let's say we have 3 dB and we want to find the voltage ratio. So we know that V out over Vn is going to equal 10 to the power of 3 divided by 20, which is going to give us something that looks like about 1.416, which is approximately equal to the square root of 2. And if we do that for power, again, 3 dB is going to be P out over Pn, and that's going to be 10 to the power of 3 divided by 10, which is approximately 1.995, which would be about 2. If we have negative 3 dB, and we want to find the voltage ratio, V out over Vn equals 10 to the power of negative 3 divided by 20, which looks like approximately 0.707, or approximately the square root 1 over, the square root of 2, or square root of 2 over 2, either way you want to write it. And if we look at it in the power ratio, negative 3 dB would give us, for the power ratio, we'd have P out over Pn, and that's going to be 10 to the power negative 3 over 10, which is approximately equal to 0.501, which is approximately equal to 1/2. For a couple of additional examples, we're just going to look at voltage ratios here, but let's say we have 57 dB. What's the voltage ratio going to be? Well, V out over Vn is 10 to the power of 57 divided by 20, and that gives us something that is approximately 708. Okay, so that's a fairly large voltage ratio. Let's say negative 19 dB. Negative 19 dB is going to give us V out over Vn equals 10 to the power of negative 19 over 20. And that's going to give us something that's approximately 0.112. And let's throw in one more. Let's use negative 20 dB. Now this one shouldn't come as a surprise. It's going to be V out over Vn equals 10 to the power of negative 20 divided by 20, which is just 10 to the minus 0.1 power. So that's going to give us 0.1. So I hope you find this discussion useful. We'll be converting back and forth between dB and unitless gain a number of times in what we're going to be doing going forward. So thanks for listening. Have a good day.